Okay, I'm going to get started. There's going to be another people trickle in as they come, but so be it. So today, thank you very much for joining me. This is a topic that I'm excited to talk about, and I'm excited to get feedback. So feel free to use the chat or interact with our team afterwards. But today we're going to talk about industrial control systems and zero trust. There's been a lot of talk about this recently, the various standards that are coming and emerging, and the ISAI state standards talk about zones and conduits and how do they interact with zero trust. And you have things like CISA and NIST standards coming out. But if everybody's trying to do effectively the same thing, which is to bridge a set of sort of seemingly at odds objectives. Objective one, real-time control systems do what they do best, which is talk with zero latency with each other with not a lot in the way. Objective two, we keep everything bad out of that. Objective three, we make it really easy to do remote maintenance for people who are allowed to do stuff. And objective four is somehow or another that becomes modern and cloud, even though those things are bolted to the wall and have a layer of grease a mile deep on them. So who's me? I'm Don Bowman. I'm our speaker today. I'm the founder of Vigilicus, and I would love for you guys to reach out after this and talk to me or my team. Particularly feel free to challenge me. Say, Don, you were absolutely wrong on that topic because, that makes my day. Now, have a reason for it. Don't just do it because, but this is how I learn. I learn by, talking with other people and getting their input on things. So these are my perspectives. So what we do, in a nutshell, we make a zero trust network access platform, network architecture, and it allows any user. So for us, that means really any user. So everybody that you work with has an online identity, and it's usually attested through Google or Microsoft G Suite or Azure Office 365. And that includes your contractors and your partners. But what happens is we create little isolated pools and we say, my company can use my Azure, but not yours. And then that means we create shadow users and so on. So we fix that problem. And the second is any device. It's very common to say, to access my thing, you need to use my VPN, but then your partners are kind of challenged, like, your VPN doesn't work in their system, they don't have licenses. And then to any resource, and a resource is a thing you need to poke your hot little fingers at. And sometimes it's a thing that a thing needs to poke its hot little fingers at. It's like that thing needs to talk to this thing. In a nutshell, what you want us to do is to make it so that I've identified the who, which is the identity. What is it allowed to do? That's authorization, and then get it there as quickly and simply and easily as possible, and that's the how. And that's what zero trust is all about, is doing that instead of from a network to a network, which is a VPN, doing it instead from a person to a singular resource. And that's what we're going to talk about, is how to make that work in an industrial environment today. So today we're going to discuss exactly that. Who is the who? So other than being a band that's still alive somehow, the who is the everybody that you need to work with. And that's a big everybody. You find that at first you think it's just, well, there's 4 people in the SCADA controls team and 2 technicians using the HMI, it's 6. And then somebody says, well, this new chiller we've bought from Siemens, they need to be able to have remote access to it on a daily basis to check something. It's part of the contract we've signed. And what does it mean to give access to Siemens? Several 100,000 people. That's a big revolving door. Are you giving a shared username and password, or are you doing it on a per user basis? And then you realize it's a whole set of other who's, and they each have a legitimate need to do a specific thing, which is to segue into the second part of the topic, which is how do you define the what? That's the role. So you don't really want on off. Access is not a Boolean. You can do anything or nothing. It's more fine-grained, it's more nuanced than that. And then the last is, how do you ensure that access? You're talking about an industrial plant that's, maybe it's a water pumping station and it's quite a distance out of town, and it has a cellular radio, or it has a, maybe a Starlink satellite, and there is no inbound connectivity because it doesn't have a public IP. And what does that mean? How do you restrict access there when the firewall doesn't allow anything outbound? But first, we're going to give you a little bit of homework. One minute on the topic. It's my question is, all access, first and third party, to my systems uses per user unique credentials. It's anonymous, no judging, but are there shared credentials involved in your universe where a company has a login to the VPN rather than a person? So I'll just give that a couple seconds to see if people want to answer it. It really only informs my witty patter during this presentation. It doesn't do much else. Okay, I'm going to call the poll at that. And it looks like we've got an even split, folks. 50% say that they have per user for everything, and 50% are liars. I mean, say the opposite. So let's talk a little bit about what is a vendor. So what is a vendor? Different people have different terms, partners, contractors, etc. But in a nutshell, there's people that are external to your organization that have a legitimate need to interact with you in order to provide their product or service. And they often require access to a subset of your things that are areas that you're kind of nervous about. And recently, things like COVID made it much less obvious that they wanted to do that face-to-face. But also, there's other reasons. It could be mean time to repair. If I need to get somebody in to change the program in that PLC, and if they're a 2-hour drive away, then my mean time to repair can't be better than 2 hours. It might even involve Hertz and United. It could be a long-distance relationship. You're starting to see more and more it's inherent. The John Deere business model of the tractor as part of the internet. I grew up on a farm. There was no internet, and the tractors certainly didn't have technology in them. But today, those things are live, connected, and they have to be. They don't work otherwise. And as a consequence, the vendor is also systems, it's the fog, it's, big data. And they each need to get access to something. And that means that has impact on the segmentation you do on your network, both in the inbound direction, but also in the outbound direction. And it has impact on the identity, how you would test who they are, etc. So why do we talk about vendors differently? They've introduced some different challenges, but nobody's saying they're necessarily a bigger security risk or different. It's not a xenophobia type thing, but it really comes down to it creates this desire to create a shared credential. I have a remote desktop machine in the lobby, and that has access to the building management systems and the HVAC. And whenever the HVAC technicians come, they just all sign in with the Post-it note on it. And then that world model became online with something like TeamViewer, because just was how we did business. But those shared credentials, the reason they're bad is that company, those people rotate, but the credential stays and typically doesn't get rotated, which means that somebody's left that organization and still has it, or it's the same shared credentials in more than one spot, or it's guessable, or one of those people themselves has a breach, but it effectively is importing their business risk into your business risk. In turn, that creates another challenge called lateral traversal. That's where we go east-west through things. We get into the thing that nobody really thought was that important. Well, the only thing this does is it prints the access logs for who's accessed the building. How could that be a big deal? It's more or less a kiosk PC, but it's on the same network that the other thing is on. That thing is an HMI. Okay, well, the HMI is a little bit protected. Oh, wait, you can sniff the traffic. Oh, it's not encrypted because it runs Windows CE. Oh, it's got the master password to the, oh, I see what's going on. And then that in turn introduces problems like ransomware walks around, people exfiltrate data, and then that's the last risk. By having these shared credentials, by having a greater pool of who, by having them come from different locations on different devices, you increase your risk by doing that. But there's still legitimate business reasons to do it, which is why we want to talk about zero trust, a way to get them to the thing they need rather than to the everything and say, just talk to the thing you need. So what are they accessing? It could be the HMI. The HMI could be a remote operator that's helping you out with something. It could be just the stats that are on it. It could be somebody that's, you're working with the vendor and you're diagnosing a glitch in it. It could be a PLC. The PLC could be somebody that just needs to read the tags. It could be somebody that needs to reprogram it. And that's a domain expertise that isn't physically attached to it. You see a lot of thin clients now, and so it could be very, very simple web interfaces that come served out of devices, like they're their maintenance interface or what have you, but it can be much more complicated. A lot of the HMIs are now thin clients, web apps. And then you see a lot of remote desktop. And for us, that's VNC and Microsoft RDP. And this is not a bad solution. Is you have a Bastion host, and then you identify a single person and you bring them into that Bastion host that then goes onwards. And that also maintains the right version of the software and the licensing. You can make that really simple for them so they can just open their tablet on LTE and click and be in your building with their single sign-on with multi-factor, and you know they did it and you controlled when. It's not a bad model to secure the world, and then onwards program your PLC or what have you from it. But your operator may need to do this. The operator might be remote. You might have partners. You might have vendors, integrators, etc. So the common challenges that I see talking to my customers is my company's security policies and my partners, they're different. And the biggest single one you find is on multi-factor. And I hear this constant refrain. I'm a Reddit fan, and I lurk in the PLC Reddit and I lurk in the MSP Reddit. And the number of times you see somebody that's effectively trying to circumvent multi-factor. And they use phrases like, tell your customer to use SMS for multi-factor and then give them a reflector so that they send it to that, and then it sends it to all the phones on your team. You've effectively removed the value of the multi-factor from the equation. So now it's first one that gets the code can get in, and they may be able to get into that reflector. You also see a problem with, if you have shared credentials, you may have a really good integration with your HR team. If somebody's walked off the plant in bad terms, their account's terminated. When you start talking about a vendor that has the same issue with their own staff, and they take them out of their own identity system right away, but if you're not integrated to that, it could be a week before you realize that that person left on bad terms and you have a shared password across them. There's also lack of privilege controls and rules across there. And you get into this all or nothing mentality about just, get the job done and, nothing bad's happened. It's human nature. We trust each other once we've met each other. But the reality is that your organization has these controls for a reason, and you want to make your job easy. You want to make people efficient, but you also need to pay a little bit of attention there and not make those things easily circumvented. So what can you do to minimize the risk? We're going to talk a little bit more about zero trust here today, but really this comes down to segmentation, right? So the smaller you can make your segments, the lower the blast radius when something bad happens. And I use the word when something bad happens here very purposefully. A big part of my philosophy in life is called defense in depth. And you can think about World War I trench warfare. There wasn't one giant trench that they infinitely defended. They had a set of ones to fall back into. And the idea was to be able to get more visibility. Somebody sneaks out of trench A and you see them on their way to trench B, and you have time to react and whatever your reaction is. But also you've got time to fall back, and the blast radius is limited. Something bad happens, they get in one layer, you get time to react, and you make it less of an asymmetric warfare. The more you can get precise, you can get down to the individual resource. User A at 2 p.m. on Monday can read the tags of PLC B. When you get there, your risk is much, much smaller, because if you make a mistake, that's the only thing that can get killed there. Multi-factor authentication. If you haven't got it turned on, turn it on. Don't use SMS, right? So use either, so the standard I recommend is called WebAuthn. This allows you to use a YubiKey or other USB-based device. It also allows you to use the biometric authenticator on your phone, or the TPM trust store in your laptop with a fingerprint. Those are really, really strong. And then the other one's really strong. It's not quite as convenient, unfortunately, is the code generator. So, Google Authenticator, Microsoft Authenticator, that's actually a standard called TOTP, time-based one-time password, and they work universally. You can have one authenticator for everything. The nice thing about TOTP, it works without a network. It can work locally without anything at all. It's just two numbers that are running in sync with a shared timer. That's very strong. The reason multi-factor works is you need at least two of the set of who you are, what you know, and something you have. You always need at least two of those. So you can't be multi-factor if it's a password and a PIN. That's one factor. But as long as you have two of those, the risks are actually uncorrelated. So the risk that somebody steals my phone is different than the risk that somebody gets my password in a breach from somewhere. Those risks don't multiply together. The third thing you really need to focus on is fine-grained authorization. It's really easy to focus on access is on, off, but getting more fine-grained, like this user, are they allowed to be an administrator of the system? Is that a specific URL endpoint? When are they allowed to access it? What does that mean? That's really important, is to get down to that level, because that also helps you limit your blast radius. And then to have detailed auditing. This is where the really big difference in a zero trust model from a VPN comes in. VPN, at best, the audit record is user connected to network, but maybe they leave it connected all the time. They got a VM that just is connected all the time. At 2 p.m. today, something bad happened. Everybody was on the VPN, and they had been for the last week. You don't have any idea what happened, and more importantly, where it went next. When you have detailed auditing, you can see user Don read file B on server C. You can see the exact audit that's occurred. When did they sign in, from where, on what IP, on what device, and what did they access, and what did they do next? Because you know what's going to happen. Somebody in your organization is going to say, okay, we had a breach. What did they get? And you're going to say, I don't know. Okay, how long were they in? I don't know. Were there more than one of them? I don't know. Those aren't good answers. A better answer is, here's the audit log with 1 million lines of detail. It's in there somewhere. You've got your butt covered. So if we look at the traditional VPN approach, this is what a lot of people, the state of the art is, and they focus very much on what the VPN is good at, which is encryption. My VPN has AES 256 with elliptic curve and cha-cha-cha poly, 305, etc. And they don't realize that the VPN is just a long Ethernet cable. That's really what we're talking about. I take an Ethernet cable from my building and I put it into your building, and we're done. You can put ACLs on it, which are, network firewall rules, but they're not different on a VPN, and they're not easier necessarily. So in the traditional VPN approach, a valid user VPNs into some bastion host, a DMZ or something like that. And then from there, they have access to whatever it has access to. And you may have some segmentation, and you might have, the Purdue type model with layer 1, 2, or level 1, 2, 3, etc. But the reality is it gets really complicated really quickly to merge those together, and effectively they become one big zone. So that secure network, yeah, they can't get back into your corporate, into your payroll and so on, but they're kind of in everything in here, because that's kind of the green zone of the walled garden. But then suddenly you realize that the world's becoming more complicated, and there's other data flows, and those data flows are making the layers disappear, and your IoT sensors are also publishing straight to the cloud, and so is your corporate network, and therefore that air gap isn't really an air gap anymore. And next thing you know, that user that's VPN in there with their compromised credentials is spreading some malware, and it walks around, and next thing you know, there's some path that can go this way. And yeah, I'm not really suggesting that a PLC is necessarily going to start attacking your payroll, but they have processors and they have Ethernet, and people can reprogram them, and you may not have an outbound firewall, and maybe that'll be what we read about tomorrow in the Wall Street Journal. So people still need to achieve the same thing. I got a vendor, I got a staff member who's remote, I got something's wrong in my plant, this pump isn't starting, and somebody needs to help me diagnose it right now. I'm losing $1 million a minute on this. I can't wait for the airplane to arrive with the person in the car. The thing I just bought, the vendor is telling me they won't sell it to me unless they have full-time access to it. It's a monitored service or what have you. The vendor's telling me that the cost to be on site is too high, and my finance team is telling me to save some money. Can we use remote for more of it? And can we make our mean time to repair go down? So these are the goals you're trying to achieve with a singular zero trust identity-based access model. So the model that I propose, and obviously without any doubt, our implementation is by far the best in the world, but coming back to that who, what, and how, the who. If you can federate the login so that people can sign in with their existing single sign-on, which is what we do, So I log in with my corporate credentials, just like I do the rest of my corporate applications. My partner does the same, just like they do with the rest of their corporate credentials. I'm not creating a new shared credential. So I'm allowing Joe at theirdomain.com to sign in via Office 365 attestation. I'm letting Dawn at Agilicus log in via Google G Suite attestation. From my standpoint as an end user, it's single sign-on. From your standpoint as operating this plant, all you're doing is trusting. Microsoft said that person was who they said they were, and I'm prepared to trust that. I haven't given them access to anything yet, but I'm agreeing that they are who they said they are. It's called federation of identity or federated authentication. The second part of our model is that centralized authorization. You can outsource identity to someone like Microsoft, but you can't outsource what they're allowed to do. That's what you own. That's core to your business. And here, this is where the VPN and its ACL rules fall down. It's really complicated to set up subnet 1 to subnet 2 with this port at this time. You know, you end up with the rule set that's larger than you can implement in your Cisco switch, and you can't get anything done with it. And then secondly, you lose the auditing because the ACL says what's allowed to occur, but it doesn't show you the individual transactions that have occurred. So this is really what we have implemented is a rule engine using that federated identity that you can express. You know, the user must request access first. The user must have presented a valid second factor. The user must be at an IP address located in the continental United States. The user must be, etc. That kind of thing becomes part of the authorization. They're in this group. They have this rule. The thing they're trying to do is in line with their rule. You know, they're trying to be an admin on the system and I don't allow them, then it's blocked rather than, oh, they can get an IP packet there. And then the last part, which is the biggest impact on industrial, is the how. How do I get them there once this is all determined? And this is the part, we have a very small piece of software that runs on site called the connector. You can run it on nearly any footprint, Raspberry Pi, industrial PC, Windows PC, Linux, etc. It maintains an outbound only connection on port 443 over TLS to our infrastructure. The nice thing about that is a lot of you will have an inspecting firewall on the way out, you know, Zscaler or something like that. And this means that all of the traffic can go through the inspecting firewall. And then we'll bring back in that connection on the outbound connection. So that site with Starlink without a public IP or cellular, this will work. You know, you got a boat and the boat's walking around the world and you don't have a fixed public IP and you need to be able to get in SSH into some switch on it. It's a good solution for you. You know, you've got a site where it's remote and it's out of town and it doesn't really have inbound anything. We're a good solution for it. You've got a corporate IT team that manages the internet gateway on your behalf, and their inspecting firewall says, if I can't inspect it, I block it. We're a good solution for that. You can bring complicated protocols like Kafka or Ethernet/IP over our system, over that WebSocket, over TLS on the way out, with the same strong encryption your VPN would have. AES 256, elliptical, Cha-Cha Poly 305, the whole jam, same security, but instead it's per transaction, per user, authenticated and authorized. And then they're only allowed to get to the one thing. It's not an IP address in the subnet that they get. It's a ability to do the thing they want to do to the thing that they're trying to get to, which is that HMI or what have you. That's the key, is it's that single person, single sign-on, multi-factor, authorized role to the thing involved. And they can't go sideways. So if their laptop has a virus, it can't go sideways because there's nowhere to go. It's not an IP address adjacency. It's a different model. So that's what we've implemented. And we've implemented in a bunch of spots. And I'll give you a little quick case study here. So here's an example. Imagine that you have a generator. And the generator is managed for you by some company that once a week does a quick test run on it, make sure that it hasn't run out of oil and that sort of thing. And the generator's Ethernet card, you're pretty skeptical that it is patched and up to date with anything because, frankly, there is no method to update it, and the manufacturer hasn't really released software for it since maybe Clinton was in office, and you know the thing is inherently unsafe, but it still have this objective that you have. So it can't be on the public internet, wouldn't be safe. It's got to remain air-gapped from the corporate network so someone can't bounce through it. Side note, there was a casino in Vegas that got hacked through their fish tank. Fairly well-known story. Fish tank had a bunch of control systems in it to keep the fish alive and the water bubbling and so on. And somebody was able to figure out how to get into that. It was on the same network that the cameras were on, and next thing you know, money. So your generator could be the back door to your thing. There's damage you could do with the generator itself. I could short cycle it on, off, burn it out. I could, during a power outage, maybe turn it off. There's all kinds of things I could do. Maybe there's a safety issue. Someday if somebody's doing maintenance and the generator starts and the line energizes, whatever it is, you got valid reasons to keep it off the corporate network. But you need to be able to get there in an emergency and have vendor access for that. Here's a great example where it doesn't have to be that mission critical PLC running that $100 million press in the back. It could be this thing here is the way in, is the segue. There's valid needs, etc. And if you look at how the flow would work in our case, the implementation of this is dead simple. You could be done by the time I finish prattling on in this presentation. You go to our webpage, click sign up. It walks you through a quick step. You're integrated with your Office 365 immediately. There's no work on your Azure backend. There's no work on Active Directory. There's no work on G Suite. It's pre-integrated. That single identity just flows. It prompts you to install a connector somewhere near the generator, probably not on it in this case, but beside it. This can be on anything: Raspberry Pi, pfSense, Linux, Windows, OpenWRT. And then that connector then makes that outbound connection, etc., to us, even behind that very restricted firewall. And now you can go into our user interface and say, user at vendor has read access to the web portal, the web admin thing of the generator. And then that vendor immediately they'll get a new valid domain name, generator.mycompany.com. They'll click, it'll have them log in. It'll be just like logging into Office 365. It might even be cached credentials, so there's no login flow. And the next thing you know, they're seeing the generator. There's no VPN they had to install. Nobody had to go and change the config of the corporate firewall. It just worked. One click, no password, and you can then turn on a multi-factor. And even you can say, if they don't have it on in their flow, then I'll force it in mine. The user will be enabled, force them to use a YubiKey or something. And now the user gets their job done, which is really all they wanted. They didn't want to understand the complexity of your corporate desires. They just wanted to get their task done and get on to their next thing. There's no layer 2 or layer 3 network adjacency here. There's no routing. They can't get to anything else. And there's no new routes installed. So it means that when this VPN, it's not like a VPN when it comes up, it breaks your Teams call. It just doesn't have that. And you have a full audit trail. You can verify who did what when. In case anything ever happens with that generator, you'll know where it came from. Why is this all important? So, a lot of you obviously realize the importance because you attended today. You gave me half an hour of your valuable time. There's a whole bunch of reasons. I need to get my cybersecurity insured. One of my clients is requiring me to hold security or insurance or something or some proof. They're going to come and audit me. Critical infrastructure. I'm part of the critical infrastructure, and our country and on some other country have been talking smack about each other, and now I'm getting probed. There's a set of standards in the space. The biggest ones come from the National Institute of Standards and Technology, SP 800 series about security, 82R3. They're mandating a zero trust infrastructure. The current and the previous president both mandated zero trust as executive orders. It's been trickling down through the state level. It's been trickling down to critical infrastructure. ISA IEC 62443 talks about zones and conduits. We've got a white paper on the topic on our website and talks about how zero trust can help you implement that. Because frankly, although the model is strong, the implementation is weak. And quickly all the zones become cross-linked and all the conduits become a big wide open highway because the world isn't the nicely layered world that we'd like to think it is. Instead, A talks to B and A talks to C, and therefore by transitive properties of the algebra we learned in grade 11, then therefore A can talk to C and bad things happen to good people. And you're seeing more and more government regulation in here, those critical orders, etc. It's becoming a big deal. And pretty soon, because zero trust is a best practice, those that don't implement it are going to be negatively impacted. It'll be harder to sell to somebody, be like ISO 14000 or 9600 that sort of linked each other's supply chains together. And I'm going to ask for your audit trail, and I'm going to ask you to federate to my identity provider to do business with me. So what's the outcome of all this? Zero trust, I mean, it's a big buzzword. You Google it, you find a million websites that talk about it. You know, a bunch of people like me pitching a strategy at you. The strategy, when you boil it down, is not that complicated. Instead of saying device A talks to device B as a VPN, and whoever's in front of device A can talk to device B and everything beside it, the long Ethernet cable, instead you say, assume nothing about the network you're in, and instead figure out who is on the left and who is on the right, and whether they're allowed to do the thing they're proposing to do. So who, what, how, who are you, what are you allowed to do, how do I get you there? That's zero trust. And then you implement it on a per resource basis rather than a per building basis or per zone basis. And, you know, in our implementation, it's effectively instant. You know, there's no re-architecture needed. It works with what's there. There's no routing changes. There's no, you know, a lot of these devices only support a singular default route. Very complicated to use with VPNs. The consequence. That's why we make jump boxes. With our system, you don't need any of that. And achieving the ultimate microsegmentation, the local config doesn't change. The segments are now fine-grained. I know who did what to them. And now I don't have to worry as much about downtime. I have to worry that, you know, the maintenance team that's logging in to change the firmware on robot A accidentally changed robot B, but robot B was in production and swung around and somebody was injured. I don't have to worry about that. So with that, any questions are more than welcome in the chat. I spoke relatively quickly today. This video will be put up on YouTube in case you find ongoing value from it. But really what we see as the value that we would create and we'd love to discuss with you is you get enhanced security. So that zero trust framework is a reason to best practice. It's still an air gap. It's a better air gap, in fact, because it's an air gap on a per thing basis rather than come into the building and then everything you can get to basis. It's got increased efficiency. Mean time to repair goes down. Maintenance is simpler. That vendor can access the thing just like you have in the contract, but not more. And the user experience is really seamless. Instead of installing a VPN on a device that's run by somebody else's corporate world and therefore they can't really do it, it's just a browser. And, you know, the browser or sometimes another app, but it just works the way they expect it. The user gets what they expect, the vendor gets what they expect, and you get what you need, which is decreased risk and increased security. With that, I will pause briefly for any questions. Feel free to type them in the chat. I will address them now.